Okay, welcome to lesson 72, solve absolute value inequalities. This lesson is not usually concentrated in the Algebra 1 course, so this is going to be a little bit different. Usually this is for Algebra 2 or people preparing for trigonometry because absolute value inequalities are a little tricky to deal with. So I'm going to do my best to explain them to you, and if this lesson helps you, then great. If not, leave some comments down in the comments section, and I'll try to do my best to make some changes and reload the video. So here's our objective, some rules and notes for you. So what we have to look at is when we deal with absolute value is that absolute value when in an equation gives you two answers. It could be the positive of a number and the negative of a number. So illustrated by the first picture. So we're going to have to take these on a case-by-case basis. When the absolute value is greater than, you're dealing with numbers outside of your boundary, the positive of your boundary and the negative of your boundary. When the absolute value is less than the other term, you're looking at all numbers in between your boundary. So you have to pay particular attention to which way your absolute value symbol is facing when dealing with absolute value inequalities. So we had to be very careful and go slowly with these examples. And then again, here's the rules for graphing regular inequalities, which apply. Okay, so now let's look at the total thing. So first thing we got to do is get rid of the 2.5. So it looks like the absolute value of x. So we're going to add 2.5 to both sides. And we have the absolute value of r plus 7 is less than or equal to 113.5. And because this Rx is R plus 7 and is less than, so it's less than this, no matter what's inside our absolute value is less than, we have to deal with both possibilities. So R plus 7 is greater than or equal negative 13.5, and r plus 7 is less than or equal to 13.5. So we have to deal with the negative possibility and the positive possibility. So our sign got switched around for the negative. So watch that. The sign got switched around, but it stayed the same for the positive outcome. So, and when we said we're dealing with less than, it includes all of the numbers in between. So please go back 2 previous slides and look at that graphic. This lesson, you're going to have to go back and really read through the rules and notes and that first picture slide. The second picture slide you've seen 10 times, but this one is a little bit different. So we subtract 7 from both sides, and r is greater than negative 20.5. We subtract 7 from both sides. R is less than or equal to 6.5. And when we go to graph it, we have negative 20.5 or negative 20 and negative 21 if you're dealing with a traditional number line. And then we have 6.5 on the left, or 6 and then 7. And then we're dealing with greater than 20.5 and less. So we're dealing with all numbers in between negative 20.5 and 6.5 will solve our original inequality. So if you put 6.5 in here, it will not work. And so let me show you why it won't work. So the absolute value of 6.5 plus 7 minus 2.5 is less than 11. So you get 13.5 minus 2.5 is less than or equal to 11. 13.5 minus 2.5 is 11. It's less than or equal to 11. And that, my friends, is true, but we did not want to include the 6.5 in for some reason. Oh, wait. I'm sorry. It is true. All right, here we go. I forgot that the 6.5 was underlined. Look at that. And so I was trying to prove it was true, and it was true. So if I would have threw in a number bigger than 7, the original inequality wouldn't, it's bigger than 6.5, the original inequality would not be true. And you can imagine a number like 7 will be up by half and things like that. Okay, so that's that one. That's our first example. Okay, so let's look at our second example, greater than. So the first thing we have to do is get rid of everything outside of the absolute value like we did in the previous one. So add 3 to both sides. The absolute value of x is greater than 8. And when we're dealing with a situation greater than, we deal with flip the sign for the negative, less than negative 8, and x is greater than 8. And we can see negative 8 and 8, open circles for both. X is less than 8, negative 8, and greater than positive 8. So what does that mean? That means if we stick a number in between here, any number in between here won't work. So let's try 0. 0 minus 3 is not greater than 5. So that proves that. So let's try negative 9. The absolute value of negative 9, because it's over here. And sometimes with these, you're going to have to test to make sure you didn't make any mistakes. 9 minus 3 is greater than 5. 6 is greater than 5. And let's try positive 9. The absolute value of 9 minus 3 is greater than 5. 9 minus 3 is greater than 5. 6 is greater than 5. All of these statements are true. So all the numbers out bigger than 8 work. All of the numbers in between negative 8 and 8 don't work. So we could put our boundaries in as tester points, and we will see what we'll get is 5, and 5 is not greater than 5. So that is an untrue statement. So sometimes you're going to have to check your work, especially when dealing with absolute value inequalities. So for the greater than situations, you flip the sign with the negative, and you leave the sign in the same direction with the positive case. You must deal with the positive and the negative case with absolute value. And so let's look at our third example. Okay, we have something multiplied to the absolute value, so we're going to have to get rid of this 2. But before we do that, we had to subtract 14 from both sides. 2 times the absolute value of c minus 1 is greater than or equal to 12. Divide both sides by 2. And we get the absolute value of c minus 1 is greater than or equal to 6. So the absolute value must be by itself. And now we can split it. So c minus 1 is less than or equal to negative 6. When I'm dealing with the negative case, I'll flip the inequality. When I'm dealing with the positive case, I'll leave the inequality alone. Add 1 to both sides. C is less than or equal to negative 5. Add 1. C is greater than or equal to 7. Let's put this on a number line. Negative 5. Less than 7 greater than. Okay, so for our tester, we want to try a number into our original inequality from here to make sure it works. So 2 times, and I always choose easy numbers because I'm lazy. 0 minus 1 plus 14 should be greater than or equal to 26. 0 minus 1, negative 1. The absolute value of negative 1 is positive 1. So this becomes 2 times 1 plus 14, which is 16, is not greater than or equal to 26. So because this statement does not work, that means all of these numbers in here do not work. You should probably try a number either 5 or 7, one of your boundary points, just to check and see what you come up with. I can mentally go through 2 times 7. 7 minus 1 is 6. 2 times 6 is 12. 12 plus 14 is 26. 26 is greater than or equal to negative than 26. It's actually equal to 26. So the 0.7 work. What about negative 5? Negative 5 minus 1 is negative 6. The absolute value of negative 6 is positive 6. 2 times 6 is 12. 12 plus 14 is 26. So 5 and 7 work. So when you're dealing with absolute value situations, use numbers as testers to test whether your solution is correct. Okay, so those were our examples. I know that was a lot. So you might have to rewind back a couple of times, and that's okay. So please watch how they were done. Please listen to the explanation. Again, this is something that is usually in an Algebra 2 course, and I put it in here just because it was next in line. So try to practice problems, and I will see you at the end of the video for a recap. Okay. The first thing you do is get rid of the 16. Add 16 to both sides. The absolute value of m is less than 20. And when we're dealing with a negative, a less than situation, we flip the sign and deal with the negative 20. And then we leave the sign when dealing with the positive. And so when we go to graph this, we have negative 20 and then positive 20. And so it's greater than 20 and less than 20. And here we go. So it's all numbers in between. So I am going to put a tester in here. Me being a lazy person I am, I'm going to put 0 to test. And 0 minus 16 is less than 4. Negative 16 is less than 4. That's a true statement. So now let's put a number outside to see. Let's try 30 because I like numbers. All right, so the absolute value of 30 is 30. So 30 minus 16 is 14 is not less than 4. That is false, and it is not in our solution set. I could probably put 20 in. If I'd have put 20 in, so 20 minus 16 is 4, and 4 is not less than 4. So that's why our boundaries do not work. So again, we proved it, we tested it. When you solve absolute value problems, whether you solve an equation or an inequality, or whether you're graphing an inequality, please use tester numbers. Okay, before we do anything, we have to divide both sides by 4. D is greater than or equal to 4. So because the absolute value is greater than, we have to deal with the negative and the positive. Negative 4 and then 4, and we have a filled in circles. D is less than negative 4, is greater than 4. So first thing we do is try a tester. 0. 4 times 0 is greater than or equal to 16. 0 is not greater than or equal to 16. Our tester works. When you try a tester in a region that's not included, it should make the inequality false. If you try a tester in the region that is included, it should work. The absolute value of negative 4 is positive 4. 4 times 4 is 16. It is equal to 16, so this works. And then we try our positive case. 16 is equal to 16, so that works. So all 3 of our testers work. And then finally with 3, add 4, add 4. X plus 11 is inside the inequality, so we stop right there. Is less than or equal to 13. So what we do, x plus 11 is greater than or equal to negative 13, and then x plus 11 is less than 13. You flip the sign when you deal with the negative case. You leave the sign alone when dealing with the positive case. Subtract 11 from both sides. X is greater than or equal to negative 24. Subtract 11 from both sides. X is less than or equal to 2. Graph it. We're dealing with 24 negative and then positive 2. And it's all points in between is in the solution set. So any number I choose in the solution set should work. So let's see. If I choose 0 plus 11 minus 4 is less than or equal to 9. 11 minus 4 is 7, and 7 is less than or equal to 9. So that works. So now we had to choose a number outside of the solution set. So let's choose 3. Now I should have put that in red. Let me put that in red. The red number is outside the solution set. So 3 plus 11 minus 4 should be less than or equal to 9. 3 plus 11 is 14 minus 4 is less than or equal to 9. 10 is not less than or equal to 9. Does not work. The red is outside of our solution set, and I'm sure if I put 25 in here, that would not work either. So now we are done. So when you're dealing with absolute value inequalities, I cannot stress this enough to please check your solutions with tester numbers. Thank you for watching. Subscribe if you like what you saw, and I will catch you on the next video. And don't forget that notification bell as well.